Every team has a set of repetitive tasks that need to be performed every single day. What if you have an agent running automatically in your application that could do exactly that job 24/7 without even getting tired? We can do that with AI by building an agent. If you have heard about Agentic AI, something like that, how to build an agent, this video is for you, because here we'll talk about how to design a system, how to design an agent as part of your applications. So in this video, you will learn how to start that journey in terms of system design. So you will see how to design a system, an help desk system, in 3 different layers: a context diagram, an application diagram, and a component diagram. And we'll see how to design those, how to start from the big picture until something a bit more granular. And during the process, you will learn what it means to build an agent. What is an agent after all? So if you are thinking about adding AI to your applications, you want to watch this video. This video is sponsored by icepanel. More on them later. Our goal today is to design an help desk triage agent. Basically, something that will stay inside of our applications, inside of our system, that will be looking to the requests coming from our clients and can quickly react to those. It can either reply to those tickets, for example, based on history, based on documentation, based on many different things that we want to input into the decision. But for example, in some cases, we want to escalate that ticket to a human. If we can't find the solution, if, for example, is an high-profile client and we want to assign it to a human. So in such cases, we can take those decisions in different ways. That's exactly what we'll do to designing our agent. But I want to start by designing the big picture. It's the way that I like to start this type of design system sessions. So we need to start by thinking about the big pieces, okay? Who will interact with this system? This system depends on which type of other external systems. So we'll start designing that, and then we go one layer below and we go into the details. So let's start first by creating a system, and our system is our help desk system. So it's the help desk triage. At this moment, I can start thinking about a couple of things. For example, where do I want to host this thing? Maybe it will be using AWS, so I can have that clear already here. Next thing that I like to ask myself is, who will interact with this thing? And the first one, the first actor, is basically our customer. So our customer will send, for example, new requests to our help desk triage. So our customer submit tickets. On that customer, I can either provide a small description on what I'm thinking that customer will be able to do with this system. And for example, I want to make it clear that it will use a chat interface to have this type of discussion, to submit a ticket, reporting an issue, checking the status of that ticket. But there's other actors in this system. For example, at some point, I want to escalate this to a different actor. So on such cases, what I will need is a support agent. This is in fact a human that will be getting a ticket that needs to be handled. So it will handle the escalation. And now you can see the process. We can keep thinking about different types of roles that will interact with our system. For example, we'll have rules, so maybe we need something like an administrator, someone with a role that is capable of defining a set of configurations, of defining thresholds, rules, settings, all those type of things. So I can bring another actor for that and have it clear that this one will configure the system. From those 3 agents, it's also important to think where they are coming from. Is it someone from the organization? Is it someone from the outside? So we can signal already here that they are coming from outside of our business. So if we zoom out just for a bit, this is how the things look like for now. But our system will not be alone in the world. We need external providers to have this running. In some cases, you will have technology, for example, given database that in fact is part of that help desk triage, so will not represent it at this first level. But what I'm thinking about is the flow of information in terms of business. So I will have a client sending a ticket. Am I using a third-party provider for something? And I will be doing it because, for example, I want to use an AI provider, something like OpenAI or Anthropic, that I want to delegate the responsibility of reasoning of that agent. That AI agent will need to use a model that will reason about my requests. So we can bring here something like OpenAI, for example, that is a system as well. It is from the outside of our organization, and I can bring here the logo as well. And we keep thinking, what type of information do I need to take the decisions about each request? And for example, if I have the profile of my client as part of Salesforce, let's say, I need to rely on Salesforce. So let's bring another system that will represent our CRM, where we'll get the customer information. So let's add the icon as well, and you can see where this is going. So we keep thinking about what type of information this help desk triage agent needs to perform his role. It might be something like I'm using this service, this other system, in order to take my decisions. It might be something like I want to store information, I want to report information to a given place. For example, let's say that for authentication, I want to use an auth system that is, for example, auth0. So come here, so I can have here something that I'm relying on to manage my authentication process. Also, I know that my help desk triage agent will need some information to take the decisions. For example, documentation. Where can I find that documentation? Is it a file? Is it an internal wiki? Is it something like Confluence? Maybe. So let's bring Confluence as well, where we'll be searching for the documentation. And now will I notify the support agent when a ticket is escalated? How will I notify the customer when there's an update to the ticket? So I can bring something like an SMTP service. Let's say that I'm using SendGrid to send notifications. So it's another system, and you see where this is going. We have our OpenAI for reasoning. We have Salesforce and Confluence, where we can find information about the tickets and the clients, so we can provide an answer or escalate our ticket. We have the auth0 for authentication. We have SendGrid to notify our users, our actors. But there's one thing more that is extremely important in every type of system, but with AI is extremely important because of, for example, the cost, that is observability. So let's bring also a system for observability. And it can be something like, let's say, Datadog or any other type of solution. What is important is that you not only share traces, metrics, logs, but also every single thing regarding LLM observability. For example, having a record of the cost of those prompts. So now you are capable of optimizing your system, understanding the cost of a given operation, seeing if in fact that agent is cost efficient or not. If I need to change the model, for example, to make it cost efficient. So this is the big picture of our system. Okay, now we know which type of systems do we need to have in place, which type of systems do we need to talk with to have this help desk agent in place. But also we know who will interact with that agent. From this point onwards, what we'll be doing is to drill down, is to go to the next level, to the application diagram. In this moment, what I want to see is what is happening inside of the help desk triage. I don't care about the granular details on how things work, but I want to see the deployable units. The same way that if you are building a given solution to, for example, create reports for your clients, that solution might have, for example, a report generator that is a service that you deploy somehow, and another service to send notifications, for example. So those two, in fact, conceptually, are a single system. That's the type of system that you are seeing at the moment, but now we are going deep down and see which type of deployable units are part of that help desk triage. So I will zoom into this one to create a new diagram. And this is the box of what is inside of our help desk triage. So if your team is responsible for the help desk triage, your team is concerned about all the things that are inside of this help desk triage. And it might be many different things. So I like to start from the outside, from the actors that we have. And we already know that we have an actor that is a customer. By the way, not all the information that we add in the layer above needs to be inside of this level, because now we are looking for specific parts of our system. So by the end, we might have different app diagrams or different component diagrams for different parts of our system. The important part is that you keep things small, concise, but descriptive in a way that in fact they represent that part of the system. So I have here my customer, and what I know is that this customer will need to interact with a chat type of experience that will be the gateway to talk with my agent. So I can say that this customer will interact with something that I will call a chat UI that is an app inside of my help desk triage. And what the customer will do is to create tickets. So I will say here, new ticket. Okay, our chat UI can be something like a React web application, and I can provide a bit more of information. So it's a React front end where the customers will submit and track the tickets. But now I need to start thinking what needs to happen for this to be a reality. And one thing is authentication. So I can bring the external system here as well. So the authentication system, we are using Auth0, and I will represent here the authentication part. And now that I have my customer authenticated, he has the chat experience, what happens with that information? I need to send that request to somewhere. So let's say that I have a system that is an API that will have that responsibility. So let's call it the triage agent. It is another application that will react to the messages coming from the chat UI. This triage agent can be implemented, for example, with .NET or TypeScript. A backend language will expose it as an API. And here is the place where the magic will happen. So this will be the responsible to orchestrate the agentic loop. We'll see that a bit more in detail in the next layer of this diagram. For now, my concern is the deployable units of our system. And what needs to happen when the message comes to the triage agent? The first thing that I need to check is to validate the authentication. Okay, if the request is coming and there's, for example, a token there, I need to ensure that is a valid token. Once I'm pretty sure that I can perform the request, what do I need to do? In a system like this, we need to have a place where we keep the history of those conversations, so in memory, so we can always go there and pull that information in. Think about it like the conversation history of a WhatsApp group, for example. Once you go back to that conversation, maybe 2 or 3 hours later, you can always go back, scroll up, and see the context of that conversation. So you need something in place like that. And a good way to do it is either having it in memory, but if you scale your agent, you'll have a problem. So I like to use something like Redis. So we'll bring our Redis database that will be the conversation memory. And in this moment, it's not an application, it's a store, okay? It's a place where we will store the conversation history and that you can go there and bring it back. So we can mark it as Redis and notice that it's part of our help desk triage. Why? This database is owned by this system. Okay? It might be a different component, it might be a different technology, but is owned by this help desk triage. So it's inside of the same boundary. So I'm keeping it together here. So I can load that information to check the conversation, but there's other things that our triage agent needs to do. For example, we need to have a way to store those tickets, get the history of those tickets, get previous tickets from somewhere. So we need another system for that, another store that is our database, where we'll do the CRUD of those tickets. And now we need to think about the technology that would serve us best. I like to use something like Postgres, pick the one that you like, is also owned by that part of our system. And while this database is great for things like creating an entry, like having a record that this interaction happened, that the client reports something, it's not great for an AI agent to look for similar things. For example, if I want to look for solutions coming from our Confluence, so we have Confluence as a wiki, there's a couple of things documented there, standard operated procedures, bug tracking, common solutions, frequent asked questions and the solutions. I might want to go there and get information, but I don't want to use the API for that. So I can bring here our Confluence. It is an external system, but I don't want this triage agent having to query the Confluence through the API because I don't know what I'll be looking for. The client might ask something in a given way, so with a given expression, and the thing that I'm looking for is close to that, but is not exactly with the same terms. This is where something like vector search comes in, because it will enable our application, it will empower our application to look for things that are close enough that might be related. It's extremely powerful and works great in AI when you are building something like a RAG, retrieval augmented generation. So we need to send that information from Confluence to another place, to a vector database. So what I will do is that I will say that our triage agent will use a vector store. That vector store is also storage that I will use for search. In terms of technology, any type of database that is capable of doing vectors will work great. So on my case, I will keep the bet on Postgres, but I will have it clear here that is Postgres with PG vector. It's a way to add semantic search and vectors into Postgres. So I will have that, but now I need a way to move that information from here into here. For that, what I need is to generate the embeddings. Embeddings is a way to go from text, converting it to tokens, okay? And then I can perform the queries exactly in the same way. From a text of the query, I generate the tokens and I look for the tokens that are close enough. So to do that conversion, what I will do is that I will bring another piece, another application into my system. So I'll create a new app and I will call it ingestion worker. This one is also part of our help desk triage system and will be the one writing the information into the store. But now I need to answer the question, how I'm going to pull the information from Confluence. It might be in several different ways. This is the moment where you go into the documentation of that technology and you see what is available. I could be doing something like frequent pulling of the API of Confluence, but Confluence has webhooks, so I can react to those webhooks. So I could take advantage of the webhook when the page updates. Based on that, I will write into the vector database. But to write into the vector database, I need to do something slightly different. I need to use a model that will generate the embeddings. So I can take advantage of OpenAI once again. So let's bring OpenAI into here, because my goal is to generate the embeddings from OpenAI. So I can call OpenAI and say, please generate the embeddings. For that, I can use a specific model that is capable of performing the embeddings, and I will use that model again when I need to perform the query. So I can use from the triage agent the OpenAI as well to generate embeddings, but also to reason about the things that are happening. So we could have here two different arrows because there's two different functions that we are taking advantage of the OpenAI model. So what is happening so far? Our client interacts with the chat UI. I need a system here that will load the conversation, the previous interactions, and that is capable of writing it to a ticket database. But for example, can go into a vector store, look for answers that came from Confluence, and look for the ones that are close enough, okay, that they are similar. They might be the ones that I'm looking for. Because then I will use that information to reason about the ticket, and I might have the solution for this. So let's pick a technology for the ingestion worker. It might be the ones that we are using so far. It might be .NET, it might be Python, whatever, okay? I'm not forced to use the same technology. Finally, we are in the moment where I like to think if I want to drill down now into the component diagram or there's something missing. For that, I like to go back into our previous diagram, first level, the overview, and see if there's something that needs to be represented as well. And for example, I don't have there our SandGrid integration, for example, and I feel it's important to have it there. Or for example, Salesforce. So let's drill down once again, and I will bring in Salesforce, observability, and SandGrid, because we are using all of those from this triage agent. So I will use SandGrid to notify. In terms of observability and Datadog, I will send all the traces, metrics, and prompts. And I need to use Salesforce to find information about my customer. Why? I might use that information to escalate my issue, to send it to someone. Let's say that my client in the CRM says that is a VIP, someone that we need to take care with extra attention. So in such cases, I might want to escalate it right away. So this is the big picture of what my helpdesk triage is at the moment. I have the different pieces that are part of it, the connections that I have with other technologies from the outside, and I know what's the typical flow. Now we can drill down once again. Now we need to focus on one of our key pieces, the triage agent. So we'll not do it for our chat UI, but typically you will have different component diagrams for each type of system that you are deploying, so each type of application. So what you'll do is that you'll go into our triage agent, create a new component diagram. So the goal now is not to talk about things that you'll deploy, is to talk about the modules, the components, the parts, the elements of that system. Imagine that this triage agent is a service, an API, and now I want to understand logically how that one is working. So what we'll do is that we'll focus on this idea of a single agent, okay? One single agent that is performing our tasks. And for that, we need an agentic loop. What does it mean, an agentic loop? An agentic loop is when our system is capable of loading the context, then having some reasoning and understanding that there's something else that needs to happen. On such cases, it can use tools and it can use that information that is collecting to reinforce the cycle. So it's like a loop that keeps happening and we keep providing a better answer because we learn with the previous executions, and the prompts and the responses can have code being triggered when something like that happens. Let's say that we have a prompt that comes back saying, let's load information about our client. So what I will do is that I will execute a small piece of code to get that client information and send it back as another prompt with the context, with the history. So I keep refining it until I find the perfect answer. That's the idea. How do we define our agent? Our agent will have three main parts. So the first part is what I like to call the planner. So I will create a component and I'll call it the planner. The planner will react to what comes from the outside. So I'll represent here the chat UI that is coming from the outside. We'll get a message into the planner. So now the planner needs to understand what needs to be done after. Since this message is basically a prompt, a user prompt, something that I'm not familiar with what is there, I want to call the LLM, okay, my AI provider, to have reasoning about what is coming. But first, what I will do is that I will use the context to have a better answer. Let's say that this message comes in a given conversation, okay? It's not the first message from the client, is a third question. So we can come here and say, I want to load the history from our conversation memory. Once I have that and I append the message coming from the outside, now let's go to OpenAI and reason about this. So in summary, our planner can be a TypeScript class, something like that, that will receive information from the outside, then will load the conversation, send it to OpenAI, and after that will forward to a next element. How do we do it? I will have another component that I will call the assessor or evaluator. My assessor is another component that will receive my LLM response. And the key goal of this assessor is to look into the LLM response and understand what we need to do next. Do we have the answer? If so, what I want to do is to produce a response. If not, it might be, for example, calling a tool. So I will call something that I like to call either tool manager or tool executor. And this one is responsible to understand if there's a given tool to be called. What does that mean? It means that at some point, this prompt here can produce a response that says, I need something else. Please go get this information and then come back to me. So that means that the tool executor can go back into the planner with the tool result. This is the agent loop. So it's reinforcing itself until we have the final answer that we are happy to reply back. How is this possible? How do we know that there's something else to execute? A great way to do it is with a system prompt. So let's create here our system prompt. And in the system prompt, we can provide information about the goal of the reasoning process. So we can provide things like the tone of voice, but also, extremely important, we can define tools. We can say, okay, you'll have available a tool to get the client information. That tool receives as parameters, for example, the customer ID, that is a string, and it will return a subscription tier, an account age in months, monthly spend, SLA response hours. So if the LLM feels that is needed, some of this information to reply back to continue the loop, then in the response we'll have something saying, please call the get client info. Eventually, the assessor will understand, okay, we need to call the get client info, so let's forward that to the tool executor. And the tool executor is the responsible to know how to translate that into code execution. Let's go into that detail now. So here is where we'll hold all the different tools that we need to have in place. For example, execute the get client info. The get client info will be basically a small adapter that will call like a gateway to call our CRM, so Salesforce. So now you can see where this is going. If the prompt says, okay, please let's use this thing if needed, now it goes back, the assessor understands that a tool needs to be called, will call the tool executor. Tool executor understands that is the get client info, so the get client info can call the Salesforce API, get information, retrieve it back, and will append it into the next conversation as a new entry, a new message, and the planner will go to the OpenAI again, and this cycle keep going. So I will quickly have here all the different tools, and this is what you have. An agent that is capable of executing several different tools that are capable of going to several different stores or systems. So this is the picture of what will happen inside of our agent. We have the loop, and it will go to different tools. And to make this agentic flow more clear for you, I want to create a flow here. But first, Listen, I know that you are looking at this and thinking, this seems so elegant, so simple. And that's because I'm using a tool to keep it exactly that way. If in your organization, onboarding takes weeks because the architecture sits on the heads of so many different people and you need to visualize it, the answer might be the today's sponsored video, IcePanel. Because with IcePanel, you can model all that distributed system that you have in place, that Kubernetes cluster, all of those things in a single diagramming tool. And then you can zoom in and zoom out to see the level of detail that you need at 2 a.m. when you are just trying to fix an issue once again. So if you want to keep your system simple and a map to navigate the complexity that will emerge after years of development out of a single product, this is the answer for you. It's genuinely great, and you can find the link in the description. How the agent will process the information. Let's take a look into an API path on what would happen once this agent, this triage agent, gets a new message. For that, let's use one amazing feature that I love on IcePanel, that is the flows. So let's run this API path flow, and what will happen is that we'll see the flow of the message. First thing, through the chat UI, we get a new message. That message goes into the planner. The planner will load the context from the memory. So after that, we have the context of the conversation. It might be empty, it might not. Now, let's go to OpenAI, use the completions API, and using the system prompt and the message that comes from the outside, let's ask OpenAI to reason about this. Then we get an answer. So we'll go to the assessor, and the assessor will take a look into the response and find, do I have all the things ready to reply back to my client? No, I don't. In fact, I need to execute a couple of tools. So let's call the tool executor. The tool executor looks into the information that comes from the outside and will start executing a couple of tools. For example, the response of the prompt said, we need to execute the get client info with a given parameter. So let's call the get client info. That will mean that we'll fetch information from Salesforce. Then we also need to execute the search knowledge tool to get information using vector search through our vector store. So let's call the vector store, and then let's return the results to the planner. The planner now will compile that as a conversation and set that information to the OpenAI once again, get the answer back, update the conversation memory because we might need to load it again, and then reevaluate if we have every single thing. Because from this response, we could decide that we still need to execute a couple more tools, or we might not. So in this case, let's respond to the customer. So this cycle might be changing depending on the case that we have. For example, if we had to escalate the tickets, it might mean that we call a different tool, for example. This is what Agentic AI is in practice, implementing it in our applications. It might mean that if you want to go a bit further, you might want to rely on practices like having choreographic or orchestrated ways of having agents communicating with each other. For example, like in hierarchy or splitting one agent in several different agents with different responsibilities, and now you need to have them communicating with each other. But this is the entry point to Agentic AI in your applications, and then this is the baseline of all the agents that you'll be building. What changes is the way that they will communicate. So I will leave the link in the description to this diagram, and you can go there, go to IcePanel, play with it, explore it, and you'll have a clear idea on how to start putting Agentic AI in place. And before you go, please leave a comment saying what's your next agent that you are going to implement. I would love to hear from you.